Hello, let's continue our Sudoku adventure with Scrabble V by Palfly Kampling. We're reaching the end of the alphabet here. So we have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have this red line in the grid. This is a triple sum line. So what we do is we take the 3 digits, let's just do over here. We take the 3 digits that, 3 adjacent digits, say these 3. We need to be able to take 2 of them and add it to the third one. So the order doesn't matter, but we could do, for example, the example here is 3, 4, 1, 1, 5. So let's just use that. So if I highlight these 3, I can do 1 plus 3 is 4. So this is fine. I can take 2 of them and add to the third. So obviously the third is going to be the largest. So the 2 smaller ones add to the larger one. Now for these 3, that also has to hold. So it's all overlapping 3. It's not just like these 3 and these 3. It's all of the overlapping 3. So these 3 are adjacent to each other. And we, the 2 smaller ones, 1 and 4, do add to the bigger one, the 5. 1 plus 4 is 5. And that has to continue as we move along. In addition to that, we do have X's and V's in the grid. That's Roman numeral. V is Roman numeral for 5. X is Roman numeral for 10. And that is the sum. So these 2 sum to 5, these 2 sum to 5, and these 2 sum to 10. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, so XV was designed for 9x9, where X is more interesting. But in a 6x6, there's only one way to fulfill an X, 4 plus 6. Can't do 5 plus 5 because it would repeat the 5 in the row. And we can't do 3 plus 7 or 2 plus 8 plus, or 1 plus 9 because 7, 8, and 9 don't exist in this puzzle. So we need this to be 4, 6. This 4 tells us that's 6. That's 4. It does put a 4 up here somewhere. 5s are always from 1, 2, 3, 4. No getting around that. All right, so within these 3, it looks like we're going to be doing either 1 plus 2 is 3 or 1 plus 3 is 4. If we omit the 1, then the 2 smallest are 2, 3, and we don't have a 5 to put on there. So these 3 contain a 1 for sure. So if you think about it, that means we can't put a 1 here or here, because a 1 in any of these would eliminate 1 from all 3 of these. So these are non-1 for what it's worth. Now these 3 also need a 1, which does the same exact elimination. These 3 and these 3 need a 1. That means this one is... Can this one be 1? Yeah, this one can be 1 and that can be 1. All right. Now the other thing to consider is that these are V's. So if I put a 1 on this V, then it's going with a 4. If I put a 1 on this V, it's going with a 4. So I actually can't put 3s at all on here because, well... Sorry, I don't know that that's 100% true. We know that either this group of 3 or this group of 3 at the very least will have a 4 in it, but I don't know that that excludes 3. It doesn't. Oh, sorry, excludes 2. 2 is what I would have excluded. Okay, but I don't know that it does. This is really the only thing to think about, unless there's more Sudoku I might have missed. I think we do need to think about this further. So, I mean, we know 6 is one of these 2, I suppose. That's not really all that helpful. So, let's say this was somehow 1 plus 2 is 3. Well, how would I do that? I would have to do like the 2, 3 here, and then this would be the 1. And then, oh, but this can't be 4. Okay, so well, first of all, this is very helpful. This can't be 1 because this can't be 4. And so, yeah, that's what I was missing. This can't be 1 because I can't be 4. And so within these 3, we need a 1, which means the 1's in here, which is going to be joined by a 4. Sorry. So this is going to be a 1, 4. And so now within these, I need a 3 so that I can do 1 plus 3 is 4, since I can't put a 5. So this is our 3 and that's our 2. And now within these, I need this to be 1 plus 2 is 3, because I can't put a 5. So that's 1 and that's 4. All right, that resolves all of that. Now these 3... what am I going to do? Well, this could be a 1 to make 1 plus 2 equals 3, or it could be a 5 to make 2 plus 3 equals 5. Is there any other option? I don't think so, because 2 and 3 are consecutive, so we can't fit a digit in between them. All right. Can I continue somehow? These? So if this was a 5, we're not doing 2 plus 5. So this would have to be a 3. So if this was 5, this would have to be 3. So we get 2 plus 3 is 5. If this is a 1, we have to do 1 plus 2 is 3. So this is always a 3. That's kind of crazy. We just don't know if it's 2 plus 3 equals 5 or 1 plus 2 equals 3. But now these three, how would I use the 5? So if so let's think about the 1 first. So if this was 1, we could do 1 plus 2 is 3, or we could do 1 plus 3 is 4, but 4 is gone. So the only way 1 works is 1 plus 3 is 4. If this is 5, then we can't do 5 plus 3. So this is always 2. Okay, that's kind of nutty. There must be something about this that I'm not quite understanding that's forcing this. But anyway, let's get this pair here. This is a 1-5 pair. So this is a 1-5 pair. And so this is the 5, and this is the 1, and this is the 5. All right. This is a pair as well. 4, 6. This 4 tells us the order. That's 6 and 4. All right, do I think about this next? Maybe. So yeah, okay. So this can't be a 1. So we can't do 1 plus 2 is 3. So the only other option is 2 plus 3 is 5. That makes that 1 and 5. And now here, can't do 2 plus 5. So we have to do 2 plus 3 is 5. All right. Well, I filled it out. I still don't quite, I mean, it worked out, but I don't quite understand how it ended up having that property. I guess I'm not thinking about it the right way. Anyway, this is a 2-3 pair for the column. That does give us roping, vertical roping. So this is, yeah, we have the 1-4 and the 1-4. So this is the 1-4. This 4 tells us that's 1 and 4. We have 2-3 and 2-3. So this is 2-3, but the 3 tells us that's 2, that's 3. And then this is the 5-6, and this 5 tells us that's 6, that's 5. All right. This here is the 6 as well. Okay. Over here, we need the 2. Over here, we need 1 and 6. The 6 tells us the order. Finish the column with the 3. All right, that's 2 and 3. We need a 1 in this box, which goes here. 3 in the corner, celebrating. The 2 is here. And then we need the 5 and the 6, and we're done. All right, really interesting constraint. I don't know that I've worked with it before. There definitely was something that was making it quite limited. But I just kind of case checked it as we went. All right, well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.